All right, well, welcome everybody, and thank you for joining us here today on this session about how Mindbody migrated 60,000 SQL Server databases to AWS. My name is Richard van Rooyen, and I'm very excited and also very proud to be here today, since I was a senior specialist solution architect working with Mindbody through this migration. With a quick show of hands here, how many of you are currently running production databases in AWS? Okay, nice, about 2/3. How many of you might be thinking or considering migrating SQL Server, or really any database, to AWS in, let's say, the next 24 months or so? All right, awesome. Well, also about half. Well, you came to the right place. Today, we're going to kind of go through the entire journey of Mindbody and kind of starting at the beginning. Why did they choose AWS? What were some of the benefits of that? We're going to be looking at their on-premise SQL Server architecture and how that changed coming into AWS. We're going to be looking at how different business decisions drove the migration planning and the tools that they were able to use to do so. We're also going to be reviewing how did the migration go. There's going to be lots of challenges along the way, so get ready for those. And then we're going to do kind of what's next when we start talking about modernization. And of course, lessons learned along the way. So with that, let's get started.
Hey everybody, nice to meet you. I'm Lior Sadan, Solution Architect with AWS. I work with our customers, helping them design, deploy workloads on the cloud, and Mindbody is one of my customers. We have a special guest.
Hi, I'm the customer. Tim Ford, Manager of Database Administration at Mindbody. In addition to that, I've also had a very long career as a data professional in total. Been involved in the community for decades now at this point. And also, one of the fun things, I started this thing called SQL Cruise back in 2010, where I would take people such as yourself out on cruise ships, and we would do training for a week and have a whole bunch of fun. Speaking of fun, let's talk about the fun that we had during that migration.
Let's go.
Real quick, though, let me talk about Mindbody. So Mindbody, I like to describe it as business in a box, a business solution for yoga studios, fitness centers, spas, and salons. We are the leader in the industry. We've got about 3 million active users globally. And you might know us by some of our other brands, ClassPass and Booker.
Yeah, I'm actually a user of your application. I book my gym classes and mostly cancel them.
Yeah, you too.
So really need it, very highly available. Maybe we can start from the beginning, right? Why moving to the cloud? What were your goals?
Well, initially, the big thing is what it typically is for most companies. We wanted to save money. We wanted to be able to convert a lot of those sunk costs that we had on the data platform specifically. You can imagine with 60,000 databases what kind of hardware we had sunk cost in, and convert that more to an operationalized model where we could dial in and dial back compute and therefore cost as we needed to. Additionally, building SQL Server databases is boring. I don't know if you guys all realize that or not. So we wanted to do fun stuff. We wanted to be able to innovate. And to do that, we're looking to be able to leverage infrastructure as code and other modern type methods of getting away from the repetitive tasks. We also wanted to make sure that as a repetitive task, the human element was involved too, because the last thing we wanted to do was have inconsistency on our builds. So that mixed with the fact that we definitely needed to look at leveraging the breadth and the depth of AWS in general kind of set us on our journey.
Awesome. And you mentioned scalability. That ties into when all this kind of started. Can you touch on that?
So who here was having fun in February 2020, going out, socializing, all that stuff? Yeah, that wasn't happening. So I'm going to back up for a second there, because that's when we kicked things off. But my first day on the job, I was pulled into a conference center, or a conference room, I should say, CEO, all these other people I'd never met before. And I was informed that we were moving to the cloud. which was great because the manager at the time who was courting me to come to the company was telling us about all of these interesting, issues that you would have to deal with the way we had things structured and structured on-prem. That all got thrown out the window. But 18 months later, we're looking to go ahead and engage with AWS. We're getting our act together as far as determining exactly what our plan is going to be. And part of that was also going to be engaging with the partner network at AWS and some of those other services that allow us to quickly accelerate our movement into the cloud.
So this is a huge undertaking, right? You have a big footprint in a data center, want to move it. Where do you even start?
Well, moving your stuff out of a data center is just kind of like moving out of an apartment, right? You need to know what you've got, what you want to move, what doesn't spark joy anymore that you don't want to move. So the first thing we did was look at what we had and what we were going to do with it more than anything else. The one thing I also didn't happen to mention on reasons to move to AWS too is we kind of were up against a clock to get out of our data center too. So other incentive on top of that for everything else. But the first thing that we did with AWS was this OLA, an optimization and licensing assessment.
Yeah.
Rhaegar, do you mind maybe touching on OLA?
Totally. So as part of the AWS Cloud Migration Framework, it's kind of broken into 3 different steps: the assess phase, the migrate phase, and then the operate and modernize phase. And throughout each one of those phases, AWS provides a wide variety of different tools and programs to support customers like Mindbody to migrate into AWS. And the OLA is exactly that. It's an optimization and licensing assessment. So it's a program that AWS offers for customers to go through and say, hey, what are you currently running and what will be the best way to deploy and operate that in AWS? And it's really built on 2 different pillars. And those 2 pillars are going to be, one is right sizing, and then the other one is optimizing that licensing stance. So as far as a right sizing perspective goes, we'll come out and we'll look at your servers and what you're running today on-prem. A lot of customers will buy infrastructure and they're saying, hey, this needs to operate for the next 3 to 5 years. So you're projecting what your needs are going to be. When you come to AWS, that's a real great opportunity to start right-sizing. Since it's a pay-as-you-go model, and you can leverage the elasticity of the cloud, you can run on a smaller footprint of infrastructure, save costs, and as needed, you can go ahead and increase that instance types. So what we do is we look at your current utilization for CPU and memory and network, and for us DBAs, look at I/O and throughput on disk as well. And don't worry, we don't just look at averages, we look at the peaks as well. So we will then come back and say, based off what we see you running at, let's say 60% CPU and this many IOPS, we'll make a recommendation and actually map out from your server and suggest an EC2 instance type that you can deploy to. So that's kind of the first part. The second part is looking at your Microsoft licensing stance. So in AWS, you can either bring your own licenses for when it comes to SQL and Windows, or you can leverage the license included cost model where you're deploying EC2 instances and you're paying AWS, and we will pay Microsoft on your behalf for those licenses. So as part of that, we want to make sure that huge SQL Server and Windows, just a little bit, licensing cost, that in Mindbody's scenario, they were able to leverage the BYOL cost model because of their mobility rights with active software assurance. So they were able to bring that in and go ahead and deploy with the BYOL. And so, again, through that assessment phase, that was really what we're trying to accomplish there. And a quick call to action to everybody here today, reach out to your account manager, reach out to your technical account manager, especially if you're thinking about doing a migration, and ask them, say, hey, I want to do an OLA. I want to know what's in my environment and what will this look like? Because here at AWS, we're all about making data-driven decisions and giving that data to our customers, right? So this will give you a beautiful presentation and spreadsheet, mapping all of your infrastructure, making those suggestions, like I mentioned, the EC2 mapping, as well as giving you the ultimate cost of what this is going to cost you, so you can have a good TCO for your SQL Server workloads on AWS.
Mm-hmm. And is this only for people who are migrating from data centers or also?
No, good call out on that. Thank you. So this is going to be for customers that are either looking to migrate from their data centers, maybe they're in a colo, or even from a different cloud vendor. They can also even run this once they're in AWS. So once you're in AWS, a lot of times we see customers migrate in and they might over-provision a little bit because they're very nervous about the migration or they want to go through that stability phase. But then after that, they say, okay, we now feel comfortable here, we want to cost optimize, and then we can run the OLA again for you in AWS as well. Yeah, good call.
Thank you, Reinhard. So let's switch gears a little bit, talk about SQL Server a little bit. Maybe you can describe your footprint in the data center.
Sure. First time talking about SQL Server. Kidding. So the way we had structured our environment on-prem is we broke it into two tiers. We have a customer subscriber tier that we call it that has those 60 to 70,000 databases. Those were all on standalone SQL Server 2016 on Windows 2016, standard edition, as mentioned. No HA. That might be one of those things that we're looking to do when we move to the cloud. And then we also have a central tier that was composed of about 4 clusters that housed 6 different availability groups spread over 3 nodes each.
Okay, thank you for that. And what's the plan to deploy in the cloud?
Well, we were looking to modernize, first of all, and get rid of some of that licensing that that Reinhard spoke about, because we have a little bit of cost there with 60,000 databases. So we looked at options for RDS. We looked at Aurora. We're still looking to do some of those things. We'll talk about that later. But we also wanted to make sure that we solved that HA issue that we had on-prem. We also were looking to continue using availability groups for our central work. And when we were determining what we were going to use for our sizing for our EC2s, we were looking at the standard edition limits of SQL Server. And because most of our workloads are memory intensive, we decided to land on a 4x size model because that maximized that 128 gigs worth of memory grant that we were able to leverage for SQL Server.
Got it. Okay, so we understand kind of what we have on-prem. We know where we want to go to. Mm-hmm. We're testing this. How does this go? So, in that move up to Oregon that we were looking at, and our data centers are down in LA, we had talked about taking care of those sunk costs first by working with moving the databases first. So we wanted to see what that was going to look like. We took some of our clusters in our dev environment. We moved those up into the Oregon region, leveraging that pipeline that I'd mentioned that we built. And then we started doing testing. And then we started to see problems in that every time there was that conversation up or down from Oregon to LA, we were seeing about a 20 millisecond latency hit. We knew our application was chatty. We just didn't realize it was chatty like a toddler. Speed of flight is not fast enough for you.
No. I've done a lot of things in tech, but I've never been able to figure out how to take care of reducing the speed of light.
So, how do you solve this problem?
Oh, God. We hit a brick wall. I mean, our plan was to not do a big bang. We had no appetite for it. It was going to be a huge impact to our customers. And even though we were in the middle of a pandemic, we still had to respect the fact that we were, the source of income and livelihood for so many, not just chains, but also individual shop owners. And we were also their conduit for their clients to health. So we wanted to make sure that we were able to minimize that. But Big Bang started to come back into the situation, and we got really, really concerned. But That's when AWS came up and started telling us about these things called local zones, right?
So you're saying big bang, you mean moving everything at
Everything
once?
at once. Yep. Close the door on a Friday, open it up in Oregon on Sunday night. Yeah.
It was impossible.
No.
So I think we proposed local zones. Maybe Rhaegar, do you want to give us a little bit on local zones?
Sure, absolutely. So a quick show of hands here. Who here knows about local zones? No? All right. About a third or a quarter. So I'm sure everybody knows about regions and availability zones, right? So in an availability zone, we have three or more different data centers. Within a region, we usually have three or more availability zones, right, for redundancy. And so as to mention, the closest region to LA for them where they were trying to land was going to be in Oregon, right? Well, local zones is infrastructure that we deploy in cities. So think about it more of like us running a data center closer to you, doing that compute on the edge, right? Edge computing there. And the idea here is that for exactly these types of workloads that are latency sensitive, right? So we see a lot of financial industries, a lot of gaming industries using our local zones for exactly that region because they're trying to put the data as close to the user as possible. And so what's great about local zones is that we have one right in LA. So our LAX local zone was available to Mindbody to be able to use that. Now in local zones, we provide customers with all of our core services, right? So we have networking, we're going to have compute, we're going to have storage, and so on. And one of the things is in local zones is that even though our services are available in local zones, some of our service, or it anchors into a parent region as well. We're going to kind of get into that here in a little bit, why that's important. So
how did local zone help you with that latency problem?
Well, let's talk first about how easy it was to go ahead and test that out. Snapshots from what we had deployed up in Oregon, and then we restored those down into the LA local zone. We didn't even have to extend the VPC because we're already there. Ran our tests, and surprisingly, we all know about LA traffic. It did definitely improve things to the point where it now freed us up of the ability to now go back to that hybrid model and step away from the big bang. Because as we said, we were never going to do a big bang. Never. No.
Awesome.
No way.
So this solves your problem, but there were a few challenges as well?
Well, there's a few challenges. As mentioned, there are some limitations to what services are available in the local zones, as well as, in some cases, where those services reside. For instance, we had planned to leverage GP3 storage, but GP3 storage at the time wasn't available in the local zone. Additionally, our backups, we back up directly to S3 with a third-party tool. And so our backups will now take longer because our databases aren't stationed close in physical proximity to our backups and our applications together. So what we ended up with was a situation where we ended up having to take some consideration in what we could do. For instance, we were looking at leveraging FSX for our file share witnesses for our clusters. But with that located up in Oregon, we did have some concerns about what that latency might mean to being able to ensure that we've got a stable environment as well.
Yeah, understood. Now, Rhaegar, I think you helped with another challenge on the storage side, right?
Yeah, that's right. So what ended up happening was, like Tim mentioned, originally when we came and did the design, went through the OLA, we did the cost analysis, and all the good stuff, that was based off of Oregon, right? So the migration to Oregon. They came out and said, okay, well, great, we're in region, we're gonna use GP3. And so they had a $1 million annual budget set for their EBS for SQL Server, and that was gonna be running all on GP3. Now, in local zone, let's kind of walk through that. So that was going to be 146 different volumes, 2.5 terabytes pop, and the kicker there being that each volume is going to require 16,000 IOPS and 500 megabits per second. Now, this was going to be for SQL Server data and tempdb files. What we saw, however, is that in local zone, GP3 was not available. So we had GP2 and IO1 was the two options. So of course we said, not a problem. GP2 cannot handle the 500 megabytes per second throughput, so we got to switch over to IO1. So we went through and re-architected everything running on IO1, and that estimate came out to be a cool $2.86 million. So just about a...
Here's a little bit to go ahead.
Thank you. Just a cool little, well, I'm going to put that in my pocket. Just a cool little $1.86 million over budget. So we said, okay, that was obviously not going to fly. We presented that back to them, and they're like, absolutely not. So we said, okay, well, let's take that back and think about it again. And that's when we said, okay, well, let's work with what we got, and GP2 being the solution there, right? So we said, let's go ahead and do a GP2 RAID 0 configuration. Now, RAID 0, this is not RAID 5, this is not RAID 10. We're not trying to solve for availability or resilience. We're just trying to solve for performance, right? So what we said with the RAID 0, that's where we're striping them together. So you can add together the performance of both of those volumes together, and that's what's going to be the performance metric. So we did 8,000 IOPS and 250 megabits per second throughput on each of the two volumes, rated them together, gets us to that 16,000 IOPS and 500 megabits per second. Now, this was with GP2 performance, there is going to be, you have to trade off because performance is based off of a capacity, right? So for each 1 gig of capacity that you grant, you get 3 IOPS on those volumes. So what ended up happening with that is that we had vastly over-provision on capacity to be able to get the storage that we wanted to. And that's one of the benefits of GP3, and that's why we recommend all of our customers go to GP3, because we disconnect those two things. So capacity and performance are not interlinked anymore with GP3. And so after we kind of re-architected all of that, we came out and said, okay, cool, well now we're down to 1.12 million, so $1.74 million savings over IO1. But we're still over budget, so what else can we do? That's when we started looking and saying, okay, what's running on these nodes or on these volumes? And again, it's going to be the SQL data file and tempdb. So we started looking at the different EC2 options that we had available to us in local zones. And then that's when we started looking at EC2 instances with locally attached NVMe SSDs that are super high speed with low latency. And we landed on the R5D nodes. That's going to be that memory optimized EC2 instance nodes that gives you 1 vCPU to 8 gig of memory. And that's the one that we selected with the 128 gig of RAM. So the R5D 4XLs were what they were ended up running with that. And so in our story, what happened there is I said, okay, well, now that we got this NVMe, what we're going to do is we're going to take tempdb and put tempdb data files on there. So by doing so, we were able to, 1, reduce the capacity, and 2, reduce the performance needs on those EBS volumes. And by doing so, we were able to actually go ahead and shrink the amount of capacity. Like we already mentioned, we were way over provision on capacity. And saw a 32% capacity consolidation, bringing us down to $768,000. But here at AWS, we're all about listening to the customer, and we're all about innovating on the behalf of customers. And so that's exactly what we did. So after working with Mindbody for so long, I said, hey, we have an internal process called a product feature request, a PFR. And so I went ahead and submitted a PFR in April 2021 on behalf of Mindbody and said, hey, team, we really need to deploy GP3 to local zones because my customer needs it. And I'm very proud and happy to say that by July 2021, they released it. And as part of that, I think you guys had an interesting little sub-story to that as well, right?
Yeah. Well, on the timing of that too, definitely I appreciate the fact that you put that in for us. I'll take that dollar back a little bit later. But we finished our migration a month after that grant was given. So we went live with the GP2 storage. But we've got some smart people that work at Mindbody, and one of our platform architects created a Python script that would allow us behind the scenes to convert every one of those stripes from GP2 to GP3 without any noticeable impact to the customer.
Yeah, that's a really cool story. And so just remember that on AWS, you can run CLI commands against your infrastructure on the back end. And it's just an amazing story about how you can convert from GP2 to GP3 in an online state. And with limited performance impact, sounds like from what Mindbody experienced, which is a really cool story. And so to kind of wrap up that piece of it, was that we ended up ultimately after the conversion of GP2 to GP3 just being a little bit over $700K in cost for them from an annual perspective there. So just kind of a neat little way of how we collaborated together, created or deployed new features to LocalZone as well.
Yeah, PFR really drives the products that we release to on AWS. Now, staying on storage, you wanted to achieve high availability for SQL Server. Can you talk a little bit about that?
Oh, definitely. So with not having the availability of any sort of shared storage in the local zone, about 10 years ago, a whole bunch of SQL MVPs were flown into this company called Sios. And I didn't really pay attention at the time because I didn't think it was going to impact me, but I remembered the product. And what Sios does is they do block level replication. And there's a process that we were able to configure that on the surface very much looked like a structure you would see for availability groups. We had identical storage underneath each node. But the way Sios works is it does that block level replication from the primary to the locked drive on the secondary. And it orchestrates perfectly with SQL Server failovers and Windows cluster failovers as well. So that's how we were able to take advantage of that and still be able to maintain a failover cluster scenario even though we didn't have shared storage.
Got it. Let's maybe backtrack a little bit. Do you want to touch on FCI maybe?
Sure. Just one of the benefits there being that, with FCI, again, we kind of touched on licensing previously, right? When we're on SQL Server Standard Edition, to get to an FCI, you require that shared storage tier, right? And on AWS, that's going to be Amazon FSx for Windows File Server. And like Tim mentioned earlier, that was not available in LAX at the time. That was only something that was available in the Oregon region, and having that latency constraint there on every read or write, that was not going to work out, right? We also have Amazon FSx for NetApp on tap, as well as more recently introduced IO2 Amazon EBS multi-attach for that shared storage tier. But just awesome to hear about how one of our AWS partners stepped in and helped out with a need there in the local zone.
Yeah, we love our partners. So.
Yes.
Yeah, they give you socks. Do you know that? That's amazing.
They do have cool socks.
Awesome. So you have a plan, had a lot of problems. We kind of solved them. How's the migration laid out?
Yeah. So there's options. AWS has plenty of different services that are available for migrating to the cloud. Unfortunately, because I was making a conscious decision to improve both our OS and our Windows editions, that kind of put us back into doing our own thing. So what we ended up doing was using our solution for our homegrown migration that we were planning for databases behind the scenes with this DB Mover tool that we created. And then from there, we would treat the AGs in a little bit different a fashion that we'll get into as well.
Now, this is a lot of infrastructure to stand up, right? Hundreds of servers. How do you kind of go about that?
Junior DBAs.
I wish. So I talked about how the partner network really helped us. And very early on, we were engaged with a partner that helped upskill us into the technologies that we didn't really know and realized that we had to know in order to do this work. So we used a tool called Pulumi to do a lot of the terraforming and infrastructure builds, and built a pipeline working with your partner to help build that out. And then this guy right here, the team lead and junior DBA, ended up shooting all of those pipelines through. And we had a little bit of issue there, I admit. Come on. I'd been familiar with this tool for all of maybe months. And we kind of over-engineered things a bit. So it took a little bit longer for us to deploy, but that was on us. The work there was seamless. We got all of that pumped out. Eventually, I'm from Michigan, so I looked at it as an assembly line. I was taking care of the deployments. We had somebody else who was responsible for those database moves, and so on and so forth.
That's fantastic. I see most of my customers are just using infrastructure and as code. Nobody's touching the UI anymore.
Yeah.
So how was the cutover, the migration?
Yeah, it wasn't too bad. We 18 months. I mean, 18 months of doing anything is rough. But after we had those initial hiccups, everything went really smooth. We were doing those database moves, scheduling them in the off hours for our customers. We partition out our subscriber tier by APAC, EMEA, and North, Central, South America. So in the overnight hours, we would move those databases slowly one at a time. And then as we were getting the application prepared and those services that matched up with our central databases in our AGs, once all of the services for supporting one AG were ready to cut over, we would leverage the maintenance windows that we have for our overnight, our monthly maintenance windows, I should say, in order to do those moves. So really, we had no need to close the front door. We leveraged existing maintenance windows we had, and we did this with very little impact to our customers.
That's beautiful. Yeah. So let's just recap kind of what we went through so far. You started the migration or kicked off the migration during COVID, had your plan, did a POC, didn't work, latency was too high. Then local zones to the rescue, you're testing that, lots of problems with storage, resolved that, you migrated. Now let's go back and look at the goals that you have for migrating to the cloud. You wanted to increase high availability, reduce cost, lower operation burden. How did it go?
Oh, you were listening to me talk. Great. So we were able to solve that HA issue, definitely. That was a big one for us because imagine having a server of 1,500 databases go down and not have HA for it. So we were able to solve that. Additionally, we were able to do some right sizing on our compute, as we talked about with how we were building out our failover clusters. And we did see that noticeable improvement in our spend through the creativity of Reghart and I in those conversations. So we were fairly happy with everything. But in order to go ahead and get to where we needed to as far as our total goals, we knew that we were going to have to maybe look at other options going forward.
So you knew that local zone is basically a stepping stone in order to really reach your goals. You have to move to the region.
We knew that we had to do another move, but we really weren't looking forward to it. To some extent, it was. We felt like we were kind of getting prompted along by our AWS team, who knew better, and were able to help us overcome our anxiety, I would say, about that move.
Yeah, I actually think that. So once you guys were all done, you were running there for a little bit, went through the stabilization phase of the project. And then when we came back, I was there. And guess what? We ran another OLA. So here's the in-cloud OLA that we ran. We said, hey, today you're spending this in local zones. We think that there's opportunity to optimize if you migrate out and into Oregon. And we helped you guys make the business case to actually kick off your next migration.
Absolutely.
Into region. And let's talk about that, because now we're back to square one again in that assess phase. What was the planning for the next migration?
Well, like you had mentioned, the inventory work was fresh in our head. We knew where everything was at. Really what it came down to in a lot of ways was what kind of time were we going to be granted by leadership in order to structure out what we wanted to do for the move. we did this, 18 months, I think. So, what's another 18 months? We were given 2 hours.
Wait.
2 hours. 2 hours. Can you believe that?
Okay, so 2 hours for the database. I mean, I think maybe we can figure that out, right? So,
well, we negotiated originally. We were looking at 6 hours for the database. But no, that 2 hours is everything.
oh, everything.
Everything.
Oh, ooh.
Database cutover, DNS changes, testing. We get 30 minutes.
Oh, okay. So now we're going from 18 months for migration down to 30 minutes. So let's kind of break it apart. Okay. So let's kind of break it apart. As you mentioned earlier, you have your central tier, and then you have your client tier. So let's kind of break it out into those two pieces. So were there any considerations for re-architecting or using any other technologies to try and accomplish that?
Well, when it came right down to it, we were kind of locked into what we were doing. We did know that we were going to take advantage at least of this migration to correct for that striping that we did,
right.
Because it's very hard to be able to extend the storage if you're working with a striped volume.
Right.
And we did find, even though we had over-provisioned for performance, at least 1 or 2 times where we needed to kind of extend to a new logical volume in order to meet the needs of things as we had them constructed. So we were going to go ahead and take care of getting that out first. And then, at that point, we were still trying to fumble for a solution there.
Okay. And so for the always-on availability groups, did you just extend that out? Or
Yeah. So the availability groups were the easy part. We were able to extend those same availability groups up into Oregon, added a couple nodes up there, 3 nodes. And hey, 3 availability zones. We could get rid of the hanky-janky, HA and DR.
Sure.
So we provisioned those extra nodes for the availability group up into Oregon. And then we leveraged log shipping, of all things.
There you go.
To log ship from the primary AG node in LA up to what's going to be the primary node in Oregon. And when time came to cut those over, then the solution would be to stop log shipping, bring that instance up, and then leverage auto-seeding to be able to eventually get back into an HA situation.
Yeah,
It's really great. We were able to, once again, be prepared on that move. The AGs were the easy part once again.
All right. So what about the failover cluster instances? So those are a little bit more tightly coupled. What did that planning and migration look like?
I was hoping we could avoid talking about that.
No, it's our favorite.
Well, we looked at a whole bunch of different options and threw quite a few of them out the window. At one point, we were looking at converting all of these standard edition clusters into enterprise edition so we could leverage enterprise edition to extend those clusters. That was going to be expensive, and it was going to require us to rebuild everything when we got up into Oregon because you can't downsize from enterprise edition to standard. So we scrapped that one right away. What we ended up deciding on, though, was what we termed the standard Oprah. And what that was is, you get a standard edition node, you get a standard edition node, you get one too. And what we did is we created duplicate infrastructure for those clusters, all new clusters up in Oregon. And then we leveraged SIOS, once again, to do the mirroring for us. So we ended up mirroring from the primary in LA, still maintaining that synchronization job to the secondary in LA. But by the nature of how SIOS works, you can only create mirroring jobs off of that primary because all of your secondary disks are locked. So at one point, as we were doing our synchronization and building out those clusters, we would start to add in additional replication jobs up to both nodes up into Oregon. We saw some impact. I mean, we're saturating that Highway 4 or Highway 5 up into Oregon from LA, and once we got into sync, we were fine. But you imagine, 100 clusters doing all that at once. It was a little rough.
Yeah, no, absolutely. And how did so now you're all synced up, you're ready to go. We got the AGs, we got the FCIs, we got our data, everything's built out over there. How did the actual night go? Were you guys able to get that 2-hour, 30-minute mark?
Did you have a problem?
Oh, God, no, you're not going to bring this up. I swore I was going to talk longer so that we wouldn't have time for this. One of the things that you have to do when you build out clusters, high availability, whatnot, is you need to make sure that you've got the ownership permission set right on those nodes, because the last thing you want to do is maybe cut over somewhere before you're expected to. So 1 week before our migration, I'm in a camper van in the middle of Eastern Washington, and my phone starts going crazy. And what I found out was that there was some communication issues in the local zone in LA, and a few of our environments, I won't say just how many, but we had at least a few clusters clusters that tried to move over early, and we had an availability group move over early. So we had a little bit of latency happening when that was going on. Sure. A lot of conversations too after the fact, but we were able to fail back fairly fast on that and get back into a situation where we're ready to go. The problem on top of that too, going back even earlier, we were in sync about 2 weeks before our cutover. And this was an 18-month project. I've mentioned that quite a few times. About 3 months before our cutover, the company decided that we were going to do an offsite, and it ended up being that 2 weeks before the event. And so on top of everything else, we had to make sure we were now ready 2 weeks before when we were doing that. And we ran into some issues because we thought we were impacting some of our customers because we were getting alerts from some of their TAMs and SAMs that they were experiencing latency. So we started turning off sync jobs and reducing things back, looking at the clock to see how long it would take to get back into sync down the road. And come to find out, it was actually, they were doing something called their Hell Week with this customer who was a fairly large client, and they were doing this to themselves. So we were able to recover. We recovered, and then we encountered that little issue that you had to bring up. Thank you so much. But when we got to the night of, piece of cake.
Yeah?
Yeah. You want to know how long?
How many minutes?
Want to guess?
31?
12.
12 minutes.
Did it in 12.
Wow, congratulations.
Yeah, it was great. We had one cluster that wasn't serving traffic that was problematic, and we were able to take care of that the next day just on our own. And other than that, everything went nice and smooth.
That's awesome.
Yeah.
I remember that weekend just sitting there and praying for you, but it went well. Now let's go back and look at the original goals, right? Cost, high availability, operational efficiency.
Oh yeah, well let's talk about cost first. In my first career, I was a production estimator. So when we're starting to talk about cost, I'm boring, DBA and accountant, what the heck? But we were able to recognize almost a 13% cost savings just with moving up into the parent region. And additionally, we expect about an 8-month ROI. So we did this in June. So Q1, Q2 coming right up, we should have our banks covered there. So that went well. Additionally, I mentioned we were able to correct for that high availability-ish type situation because we could now use 3 availability zones to do the work for us. So on top of that, the big one is we were able to improve our backup and recovery by 30%. So one thing I wanted to just pin on that a little bit too is, there's certain things that no matter how much virtualization you have, it doesn't solve everything. And if you don't have that physical proximity or at least a fast ability to recover quickly, then you're impairing your availability or your ability to improve and reduce that RTO that you got. we were able to do that. We were able to, once again, improve on our transaction log backup cadence by doing so because of the nature of the hardware we're now running on. And ultimately, nice and smooth. We hit our mark.
That is beautiful. So I know we're working, actually we have a meeting right after this session.
And I'm not kidding there either, are you?
About what we're going to go do next.
Yeah. Actually, feel free to read the slide, but since we have been practicing and rehearsing this for months, things have changed and accelerated quickly, as happens in the cloud. We are currently going through an application modernization lab, AML.
Yep.
And it's not just application. The meeting I've got coming up next is about the database to see if we're able to finally look at manipulating, converting over from SQL to Postgres as an option because that licensing is still a hit. And we definitely want to get away from the Windows licensing and the SQL licensing if we can.
Yeah, that is a wonderful program, and we are trying to kind of modernize and allow you to innovate faster.
Yep.
So this was an incredible story. I'm sure it was, you have a lot of scars and you learned a lot. Maybe you can share a little bit of those learnings.
Yeah, definitely learned a lot. I had a mentor early on that said, if you've got 25 years of experience doing the same thing, then you have 1 year of experience. And this definitely stretched all of our team into new areas that we hadn't expected. So, looking at some of these lessons learned, I'd like to focus on the fact of train. I've always been a huge advocate for learning, growing, and sharing, and I stand by that. So if you're going to encounter something like this, or you're looking at, jump in and start reading through everything, digest blogs and all the other options that AWS provides to learn about the AWS tooling and services. Enlist those partners. You can't do it alone. There's so many things that we didn't know about what we didn't know. And having a good, solid partner base that knows the ins and outs of the breadth and depth of AWS, that was priceless for us.
That's fantastic. I think we have maybe 2 minutes, 3 minutes for questions, if anybody wants to ask a question.
Yep.
Yes.
When you did the project to migrate to the region for the SQL environment, did the front-end applications also up there?
Yes. So when we, I'm sorry, the question is did we move the applications into the local zone when we moved the database files?
Into the region.
Oh, into the region. Yes. So as in that 2 hours, I should say, of stress and anxiety, that's where they got their turn also. So for this move, we did actually shut the front door for 2 hours. That was the trade-off, and that was kind of the negotiation. Is how much time would we need to be able to do this, and that's what we were able to negotiate. So once we moved the data platform up, then it was the application and infrastructure turn to do their things. Yes?
For the AWS companies, why OAZ versus direct connect from the data center? Because that's how we solve one of our limitations.
Yeah, absolutely. So I believe you guys had direct connect.
Yeah, I was going to say the big thing with the data center was the fact that we were trying to get out of it.
Yeah, and so they had direct connect, but the latency was still just too great. And it's really based off your architecture, right? So as DBAs, we all know certain applications are very chatty. So if you make, if you have many smaller queries that are like singletons, like give me this one piece versus like batch-oriented queries where it's like, hey, bring me back 10 or 100 records, stuff like that. And that's kind of what we saw in Mindbody's application, where it was making many small calls versus fewer larger calls to get the data sets back that was required. And so because of that, every single transaction is incurring that latency cumulatively to load that page or to return that back to the end user. Then you have to kind of add up every single 20 milliseconds on top of that, versus if you're only making, let's say, 1 or 2 database calls, you can absorb that into your timeout period for the query. So that was what ended up happening there. But they did have a direct connect, but it still didn't solve that problem for them. Yep.
So any challenges or issues you faced going from data centers to local zones, local zones to regions, with encryption of the data?
No, encryption was still managed as it is underneath the scenes with SQL using encryption, and then our backups are encrypted at rest as well. So our encryption scheme just followed our data moves.
Yeah.
Yes.
Yeah, so TDE encryption is going to provide you that encryption on disk, and then you can use TLS to encrypt on the wire as well. And that's still completely available. Yeah, go ahead.
When you did the OLA, did you guys find, were there any surprises? Were you like, oh my gosh, we found this whole group of SQL Server licenses sitting over here at this business unit. We didn't know about it. Was it, when you got that assessment, was it pretty much what you thought it would be, or was it quite a transformative, like light bulb moment, you know?
So the question was, did anything pop out that we didn't know about during the OLA? On the data side, no, because we're DBAs, we got our stuff together. But with wanting to go back to a job here on Monday, I'll just say that I'm not sure if that was the same on the application side.
Yeah, absolutely. And kind of to continue on that, with the OLA, the discovery can be as wide or as narrow as you want it to be. In our scenario, we did multiple OLAs just on the data tier itself, since that was the SQL Server licensing that we were trying to focus on. The OLA definitely can extend out to cover your application stack as well, where we're going to be focusing on that Windows licenses as well, and to see, hey, how can we maybe move that application to that .NET code to cross-platform .NET, get that running on Linux, get that running on Graviton to try and see even additional cost savings on top of that. But the OLA, yes, we see a wide variety, and I don't have the numbers in front of me, so I don't want to get misquoted, but it's something in the range of like 30% that we see on the right sizing, and somewhere in the range of close to 50% on licensing cost savings opportunities that we see around our customers. And,
just the optimization part, right, reduces the CPUs, and then you don't need as much.
That's right. Good point. So both Windows and SQL Server is core-based licenses. So just by default, by reducing your core count from right-sizing, you can save cost on your licensing as well. And again, like we mentioned before, you have that bring your own licenses because we want to try and protect your investment that you already made, as well as augmenting with that license included cost model as well for anything. And on AWS, you don't need to pay for your lower environments either. So any non-production workloads can run on something called SQL Server Developer Edition. That's completely free and does not require any licensing as well. So absolutely, the OLA is a great tool, again, to get those insights, to make those data-driven decisions. And with that, we actually have on screen over here a QR code that calls that out. There's that AWS Cloud adoption framework that I talked about earlier, as well as that optimization and licensing assessment.
Oh, shoot. That just triggered something that's going to make me have to go back and do some work. I realized we haven't converted from IO1 to IO2 on our central tier.
Oh yeah, that's a good point.
Wow.
Another call to action.
Oh my gosh.
Another call to action there. If you're still running on GP2, convert to GP3. If you're running on IO1, convert to IO2. Both of those will save you costs, give you more flexibility, and I'd like to mention, that conversion can be done uptime as well.
Just keep on finding new ways to change things and save money.
Love it. With that, we're just going to go ahead and wrap it up. We'll take that question afterwards. We just want to wrap it up and say thank you so much for being here today. We really do appreciate your time. Please go ahead and fill out that survey when you're done. And just like Uber, we like 5 stars. So
Exactly.
I heard that joke earlier today, so I felt like I'll give it a
Rate you back.
But thank you so much for your time today. I really appreciate it.
Thanks.